we want to find the quotient and reduce it to lowest terms. So number 1 says x minus 2 divided by x squared plus x minus 2 divided by the irrational expression x squared minus 3x plus 2 divided by x plus 2. So this is really x minus 2 divided by x squared plus x minus 2, that rational expression divided by x squared minus 3x plus 2 divided by x plus 2. Now in class, how do I divide two quantities? Well, I can divide two quantities by multiplying by the reciprocal of the divisor. I'm dividing by x squared minus 3x plus 2 divided by x plus 2, so I'm going to multiply by that reciprocal. I'm going to multiply by the reciprocal, which is x plus 2 divided by x squared minus 3x plus 2. Now it's just a multiplication question. This is the only thing new from what we did yesterday, is this division is really just multiplication by the reciprocal. So when we deal with rational expressions, we want to factor. We always want to factor the rational expressions when we work with them. So x minus 2 divided by what multiplies to negative 2, that adds to 1. Well, that's x plus 2, x minus 1, times x plus 2, and that denominator, it's a trinomial leading coefficient of 1. What multiplies to 2, that adds to negative 3, negative 1, and negative 2. So when I multiply rational expressions, I can simplify them as long as there's a common factor in the numerator and the denominator. So x minus 2 divided by x minus 2 is 1. X plus 2 divided by x plus 2 is 1. So what am I left with up top? I'm left with a 1 divided by x minus 1 times x minus 1, which can be written as 1 over x minus 1 squared. Either of those two answers is appropriate. Number 2, 6x divided by 4x minus 16 divided by 4x divided by x squared minus 16. So again, we want to factor. We can't factor 6x, but we can factor 4x minus 16. That's 4 times x minus 4. Whenever I divide, I want to multiply by the reciprocal. So I want to multiply by x squared minus 16 divided by 4x. Well, x squared minus 16 is the difference of perfect squares. So that's x plus 4, x minus 4. And when we multiply, we want to simplify common factors from the numerator and the denominator. There's an x minus 4 factor. Goodbye. Those are gone. And we're left with, oh, there's also a factor of x. There's a factor of x there and a factor of x in the denominator. Those divide out. So I'm left with 6 times x plus 4 divided by 4 times 4 is 16. Notice this is not in simplest form yet because we still have to deal with the quotient of 6 and 16. Both of those have a factor of 2, so this is 3 times x plus 4 divided by 8, because if I divide 2, they both have a common factor of 2 that I can simplify. That's my final answer. Alrighty, to divide, we multiply by the reciprocal. We multiply by the reciprocal. So we have x squared minus 7x minus 8 divided by 1 minus x squared times the reciprocal. 3x squared minus 4x plus 1, 9x squared minus 1. So we factor. We factor and we get x minus 8 times x plus 1. 1 minus x squared is the difference of perfect squares. It's 1 minus x, 1 plus x. Yes, you have to write it that way because 1 is in the front seat, and 1 has to be the front seat when I factor it. This trinomial is a leading coefficient, and there's not a GCF, so let's go over to the side and do the AC method. What multiplies to 8 times c? What multiplies to 3? That adds to negative 4. What multiplies to 3? That adds to negative 4? Well, that's negative 3 and negative 1. So I'm going to split up that middle term. This 3x minus 1x plus 1. From the first two terms, I'm taking out a 3x, and I get x minus 1. I want an x minus 1, so I'm going to have to factor out a negative 1. So this trinomial factors into x minus 1 times 3x minus 1. After I take out that GCF of x minus 1 there. And again, we have the difference of perfect squares, 3x plus 1, 3x minus 1. Now we can simplify. We can simplify as long as there's a common factor in both the numerator and the denominator. There's no x minus 8s. Do I have any factors of x plus 1? I do, because 1 plus x is actually x plus 1. That's the commutative property of addition, so those divide to 1. 3x minus 1, 3x minus 1 divides to 1. And then I have an x minus 1 and a 1 minus x. They do simplify, but it leaves behind a factor of negative 1. So now we get our final answer of negative 1 times x minus 8 divided by 3x plus 1. You could also just put a negative outside of negative x minus 8, 3x plus 1. You can distribute it in, but why do more work than you have to? Either one of those two answers is appropriate. Number 4, we have a complex fraction here, and a complex fraction is really just a division question. You have the numerator, which happens to be a rational expression, divided by the denominator, which also happens to be a rational expression. When I divide two rational expressions, I multiply by the reciprocal. So x plus 4 is now in the numerator, and x squared plus x minus 6 is in the denominator. To save some time, I'm going to factor that into x plus 3, x minus 2, because negative 2 times 3 gives me negative 6, 3 plus negative 2 is 1. Now we have to factor the first rational expression, x, what multiplies to negative 3, that adds to 2, plus 3, x minus 1. Leading coefficient of 1, so what multiplies to negative 4, that adds to 3. What multiplies to negative 4, that adds to 3. That's x plus 4 and x minus 1. So what common factors do we have here? I have an x plus 4 in the denominator and an x plus 4 in the numerator. Those divide to 1. X minus 1 divided by x minus 1 is 1. And x plus 3 divided by x plus 3 is 1. Remember, you can't start dividing things out until it's in factored form. What's left in the numerator? What's left in the numerator is a 1 divided by x minus 2. If you had to pick which expression you would rather plug a value into, I'd rather plug a value into this expression than that one, because all I have to do is 1 divided by x minus 2. This one's a little bit more complicated. That's why we simplify these rational expressions. They're equivalent. They look different, but they're actually the same thing. They have the same value. 5. Explain how the division of two quantities is related to multiplication. This is such an important idea for dealing with division of rational expressions. Explain how the division of two quantities is related to multiplication. So, if I divide two quantities, I can multiply by the reciprocal of the divisor. I can multiply by the reciprocal of the divisor. Where those lines come from, of the divisor. That's the big idea for dividing two quantities. If I want to do a divided by b, that's really a times multiplied by the reciprocal of the divisor, a times 1 over b. So that's a huge idea, that when I divide, I want to multiply by the reciprocal. Number 6, one of two numbers can be represented by the rational expression x minus 2 divided by x, where x isn't 0 and x also can't be 2. The only exclusion we really have to include is x not equal to 0, because that's when I would be dividing by 0. Right now we don't need to exclude x equals 2, but we're going to see why once we answer the question why we want to. Find a representation for the second number so that the product of these two numbers is 1. So I want to multiply two numbers together. I know this is the first one. Times what gives me 1. So there's a couple of ways to look at this question. I could think of, well, if I want this to multiply to 1, I have an x minus 2 in the numerator, I'm going to need an x minus 2 in the denominator. I have an x in the denominator, so I'm going to need a factor of x in the numerator. If I multiply those two together, I will get 1. So the other number that we're actually looking for is x divided by x minus 2, which is why in the original question they excluded 2 from the domain of this rational expression. Another way you could have looked at this is as a division question. What's 1 divided by x minus 2 over x? It's that quantity right there.